Hey, what's up, everybody? It's Papa Bale, and welcome to the channel.
Welcome in.
I got my Utron here. We're going to pump it up at 12 volts. It's just a rotor. It's made out of plastic. If it's generating any additional voltage, it's static electricity.
Static.
Just saying, right now, before we get all excited, this is plastic.
It is plastic.
These bearings are awesome, though. These are really good hybrid ceramic and steel bearings. They're even missing a ball in there for added speed. They're designed that way. It's pretty sweet. So I'm going to get it started, and we'll see how fast we can get it. We got this big black thing here just to show you how fast it's spinning. That did not work. So we have to go again. Damn, dude. So I did not mean to do that. We gotta get this up here again. A wise man might have paused it, but we're gonna get it. We're gonna get this. All right, here we go. I don't like wise people that much. They're no fun. Here we go. Come on, man. Just stay there. All right. Nope. Yep, we got it that time.
Nice.
All right.
All right.
Now, how this is wired, we got the transistor, which is right here, and then it goes into the 18 gauge, and then the 20 gauge, and then it goes around to this 20 gauge, so it kind of wraps around the thing like this.
Listen to that.
Yeah, it's loud, but that's just because this bearing on the bottom is in the groove of the other bearing. So it's like the balls are touching.
Got it.
So it's just like a grind. That's all. See, you can't see the black thing anymore. Can't see the black stripe that I put on there very much.
Yeah, that is sweet. Sweet.
Alright, now I'll stop it. And that's off. Now I gotta find a way to maglev it so that it can float on the pole.
Right.
Right now it's resting on this coupling down here. And that's what's making all the noise.
Got it. I see. Okay.
But the 18 and 20 gauge coils wrapped around this thing make it super sturdy. Like it can go really, really fast without shaking the pole.
This thing
It's awesome.
This thing is. I thought it was going to be a lot louder than that.
It is if I turn the bearing the other way.
Oh, got it.
Yeah.
Okay.
Then it's really in the groove.
Good deal.
And right now, what we're doing is we're using this power supply and this circuit to charge the battery to the right side battery, the one with the 3 clips in it. One with the 3 clips in it. This one. Yep. All right. And right now it's at 12.3. So we're going to turn off the charge. Well, 12.29. Not bad. We're going to turn off the signal generator. I like using the signal generator to pulse the transistor of the circuit that's charging the battery, so it charges up nice and quick. And then we're going to turn on this circuit, which charges the capacitors, and that's this switch right here. So now these 2 meters will go up. And the speed of the rotor here will speed up.
There's some vibration in that wire, which is sweet. And then these will speed up.
Yep, this one will speed up as the cap bank goes up. You'll get more voltage in the cap bank, so the wheel will go faster.
Got it. Look at that. Look at that.
That's awesome. And from a flip of a switch, we are force charging the capacitors of our closed loop.
That sounded amazing. Let me try to get a wide shot on that whole system going. Wow.
And then, yeah, you can even see it now. It's getting faster and faster and faster and faster. Every other minute, this is getting faster. It's because the cap bank capacitance is going up. Voltage is going up. And then when it gets up to 10, the cap banks get up to 10, it'll go even faster, because then you get the force charge actually runs the motor.
Here's another look. And then this wire, I love that.
Oh, the vibrating wire?
Yeah, it's alive. Oops, sorry about the finger.
Alright, so we're going to stop this. Okay, see, I can see how it's misaligned a little bit right now. We're going to back this one over here like that. We're going to back this one over here like this. And then we'll scoot this baby in here like that. And I just let it go. And look at that. That's super cool. But now that it's lined up like right, let's look at it one more time. It's lined up right here, and then the switch is on the side. So when the switch hits, right there, the magnets are right there on the edge of the electromagnet, and that's where the most power is. Coming out of the edges like this. So it's right. It's just right.
Yeah.
All right. So now the caps are up to 6 volts or so, 7 volts, and the battery's down to 11.97.
And that one is maglev.
Yeah, this one is maglev. So we got to turn this one off now, because the battery's it's below 12. So we turn this off. These start draining. And if we put a generator coil, they'll drain slower, or they won't. You'll see. It's pretty stable drainage. The way that is goes down pretty steadily. Doesn't like rebound very much.
And this is because the whole system is using this energy to store.
Yep, it's moving on its energy, and there's nothing really giving it any energy back. It is hooked up so that it'll go through the system, and then the end of the system is hooked into the cap bank, so it'll filter back into the system. But it's not a lot. It's not enough to make a difference. It is draining slower than it would if I didn't do that. So that's a lie. It is making a difference.
It is making a difference.
It is draining slower than it would be if I didn't make that connection.
It's going even slower, it looks. I don't know. It's probably it. We gotta.
Let me get my coil. All right. We'll worry about that later. But look at how fast that's going now, man. I mean, look at that. That is beautiful. And thank you very much.
Yeah.
We're working it out. See you in the next one. Peace out. Bye now. Have a good night. Please subscribe. Bye.